Hey guys, we're continuing from video one. Like I said, I covered three topics there, and the remaining two I'm going to go ahead and cover here. This was our lesson 1.1. All right, so the fourth topic was power functions. This one's going to be really quick. As of just for now, know that power functions are of the format y equals a times x to power of n, which means a is going to be a number and n is going to be a number. A just can't equal zero. And they're single terms, so no plus minuses, just one single term depicting an a value and an n value. So for example, if you look at a, this is in the format of a power function, so we're going to call that power function. If you look at b, because of that plus one, this would not be considered a power function. And this comes in later, so I will explain more detail later. Just for now, I'm going to keeping it brief and quick. Now, for this function, which is not a power function, this is a power function. And the reason we talk about it because functions behave like they're power functions on the extremities, like on the very far right side or the left side. We'll talk about that later. If I look at C, the A value here is 2/3 and the N value is half, so it does qualify to be, and a single term, so it does qualify to be a power function. This one also qualifies to be a power function. A value is 1 and N is -1. This one does not qualify to be a power function, neither does this. And that's it for power functions for now, being able to identify them. Moving on to topic number 5, and you have access to these slides, like I said. There are some extra slides and extra practices for even odd. Feel free to look over them. I have answer slides also posted in there. All right, now last topic is number 5, operations with functions. If you remember, operations are being able to add, subtract, multiply, or divide. Those are basic operations, but we're going to be doing them with functions instead, which means I have to have at least two functions to be able to do operations with them. And let's say they're called g of x and f of x. Also, we'll do operations in two ways, algebraically and visually, like graphically, both of them. Next are these four regular, like generic way of writing sum and difference and product and a quotient of functions. So please identify and know how to read them. If you see f plus g of x, that is exactly the same as f of x plus g of x, which means whatever the input is, we plug in the input here, evaluate the function, and then plug in the input here, evaluate the function, and go ahead and add them. If we have a specific value for the input, for example, if we have x equals 5 provided to us as the input, then we're going to plug in x value 5 here. If we do not have any particular specific x value and we have the function itself, then we're going to add the functions themselves. For these four here, the idea is you being able to read them. So for example, if you have f minus g of x, where x is the input, we can rewrite it as f of x minus g of x. And order matters because this is subtraction, and in subtraction, order matters. This represents multiplication, which means f of x times g of x, and this represents quotient, so f of x divided by g of x. And g of x cannot equal 0 because we cannot have a 0 in the denominator, because that's a no-no. That's an undefined situation. All right, let's do some easy examples here. Here's my first example. I have a function f of x, and I've also been given a function g of x. So I've been clearly provided two functions. When I look at the first option, it's asking me to add them, which basically means f of x plus g of x, like we just read before, which means I take the first function, to that I add the second function. From here, it turns into algebra 1. Am I able to add like terms, rearrange it in decreasing order of powers? And I have added them together. Since I was not given a specific input, my answer, the answer to the sum of this function, is a brand new function. If I were to work on the second one, then f of x minus g of x, be careful with subtraction. When we're subtracting, the entire second function will swap its sign, and that would be subtraction. Just rearrange them, combine any like terms, and I have subtracted the two functions. One more time, the idea is that when I added these two functions, subtracted these two functions, I got a brand new function which represents the difference of those two functions in that order. Okay, moving on to multiplication. So f of x times g of x. Since these two functions given to me are polynomial functions, all this addition subtraction is super easy. Plus 3 times the other function, and that's when we're going to use our distributive property. So multiply these two, which is 8x to the 5th plus 3, rearrange them, and we are done. Because none of these are like terms. And I am done multiplying them. So the product of these two functions, f of g times x, is again a brand new function, which is to the 5th power. Division over 4x to the 3rd plus 1. And with this question, we really can't do anything else because none of these can be factored. Number one, please don't be thinking of canceling these because we cannot cancel them when they're part of something. Bottom is degree heavy, so basically degree in the denominator is 3 and the numerator is 2, so we can't do long division. This is it. This is how I will write f of x divided by g of x. Like I said, the two functions given were polynomial functions, so it was easier, relatively easier. We could be given rational functions. Let me see. There's rational function. Actually, here's addition, subtraction. So I've been given two rational functions here, this and this. So when I'm trying to add them, I'm basically into that part of algebra that handles adding fractions with unlike denominators. Because the denominators are unlike, got to multiply them with each other to make common denominator, but then you gotta do this, now we're gonna do that, and then now I have same denominator, x minus 1 plus x squared plus 2x, that's x squared plus 3x minus 1 over x minus 1 times x plus 2, or I can even multiply the denominator. But here is the addition to that, which is something you've done in algebra too. It's just a matter of how good or how comfortable we are with our algebra. This would be pretty much the same, except we would have subtraction on top. So if I were to change this step, minus x squared minus 2x, everything else will be the same. Minus x minus 1 over x plus 2, and I have subtracted them to the best of my ability. X squared plus 2x minus x minus 2. I was just talking to myself here. And then multiplication and division. We're going to come back and do multiplication division some other time because I have not assigned it on homework yet. What you will see on this homework and the next homework will be given polynomial kind of functions and be able to do the addition subtraction. The next thing I want to show you with the same concept is what if we are actually given specific input. Like I said earlier, when you're given the x value, what do we do? One more time, I notice that this is addition of those two functions, so I go ahead and rewrite it. It basically means f of 3 plus g of 3, which means I need to now evaluate f of 3. So let me do that here real quickly. 3 squared plus 3, and that's 18 plus 1, 21. So we got that part, plus g of 3. So I got to plug in 3 here and evaluate that. So that's 27 times 4, 108 plus 1 is 109. I know I kind of did the computation part quickly, but you can do computations. And that turns out to be 130. And we have added both the functions at that particular value. If you look at the third one, this one's saying f of negative 1 times g of negative 1. Well, both functions need to be evaluated for negative 1. Negative 1 squared plus 3, that'll be 2 plus 3, 5. So this one's 5, and g of negative 1 would be negative 4 plus 1, so negative 3. So negative 3, and that gives me negative 15, and we are done with those two. And similarly, the other two, let's do the division. F of 1 divided by g of 1. So 1 would give me the same 5, and g of 1 would lead to also 5. and that will turn out to be 1. That's computation when X is provided. The third category in the same under the same topic is visual using graphs. So let's get there. Here we go. So over here, if you notice, I really haven't been given the equations of the functions. I have been given a graph of the functions. Let's call that f of x, and let's call the red function, or the orange function, as g of x. So when I look at the first one, this one's asking me f of 2 plus g of 2. So let me find f of 2 using the graph. Input value is 2, so I go to 2, and then go towards the f function, which is this one, and get the output there, which is 1. Plus, for g of 2, I go back to input value 2 and go towards the g function. Oops, and the output there is 4. So this is basically equal to 5. It's pretty easy. You really don't have to do the algebra. You just need to know how to read the graphs. Okay, f of 3 minus g of 3. So let's do that. Go to input 3, which is right here. Go towards f function. The value there is 4. So 4. And a minus g of 3, guys, is also 4. So the answer to this is 0. Let's try one more. You're welcome to pause the video and actually try it yourself. Go to 0. Go to f function. The output there is 1. And g of 0 is 4. So the answer to that's 5. Minus g of 2. We already did that earlier. If you notice, right here, we already know f of 2 is 1 minus g of 2 is 4, except it's minus, so that would equal negative 3. So that takes care of the last two topics, power functions and operations with functions. Operations with functions as graphs. That's format Excel. So operations with functions with graphs, operations with functions when you're given a specific input, which was this one, specific input, and then also operations when you're given the function in general. Hope that was helpful. I will see you in class.